Hello. Welcome to the seventh lecture for the Mathematics Class 11, Chapter 7, Binomial Theorem. So we have already seen what exactly is binomial expansion, how we expand when we are given sum of two values or two variables, and the entire the sum and the difference is raised to some power of index. And so we also saw how it is proved that for any positive integer n, the entire expansion, the binomial expansion, it is true. Till yesterday, we also saw few of the rules or few of the observations that can be used by us while we are trying to solve examples. Now, there are a few cases, okay, special cases, or again, some things that will help us in trying to solve these binomial expansion or binomial theorem problems. Okay, so as per your binomial theorem for any positive integer n. Okay, so Pn, as we had seen, so that says that a plus b the whole raised to n is equal to nc0 a raised to n plus nc1. So you can put this over here. A raised to n minus 1, b raised to 1 plus nc2 a n raised to minus 2 b2. Then any middle term, any general term that we have, c3 a n minus, sorry, this will be r. So for any time we have any r value, b raised to r plus, and then the last term is n c n a raised to 0 b raised to n. Okay, so this is what we know, that for any positive integer n, this expansion holds true. Okay, so now let's take a few special scenarios or special cases. Suppose your a is equals to x and b is equals to minus y. Okay, suppose this is what we are given. So when you write, a plus b the whole raised to n, it can be written as x plus minus y. Okay, suppose you write it in this form. And okay, so now when you expand, you normally would, expand it in the sense that your n c0, your x would be raised to n, minus y raised to 0 would be 1. So we are not going to write it. So the next one would be plus. We are just following the normal binomial expansion that we have seen. Okay, and then we are going to input the values of a and b as x and y. So you have n c1 x n minus 1. Now you will have minus y raised to 1. Okay, then again you will have n c2 x n minus 2 minus y raised to 2 plus n c3 x n minus raised to n minus 3 minus y raised to 3. Okay, plus the last term that we have is ncn minus y n. Okay, so this is what we get. Now, if you take out your minus y from the bracket itself, what you will get is n c0 x raised to n. Okay, so the first term remains the same. Then you will have, now over here the minus sign comes over here. So minus n c1 x raised to n minus 1 y. Now over here you have minus y squared. Okay, so minus y squared will give you y squared. So since that becomes plus, so this sign remains the same. So you have plus n c2 x n minus 2. Okay, and this becomes y squared. And then the next one you have minus y cubed. So any negative number when it is cubed, you will the result is going to be a negative number itself. So you will have this negative sign, and hence this sign will change. So this will now become minus n c3 n, sorry, this would be x n minus 3 y. Okay, and now if we come to the last term, we will write plus. Okay, since we do not know what this n is over here. Okay, so what we can do is that we keep this minus 1. Okay, what the minus sign, the negative sign, you can keep it as minus 1 and write the last term as this. Okay, so no matter what your n is, you can the sign of the of the term can then depend on your, yeah, this will also be yeah. So the sign will depend on your n. Okay, because any thing like minus 1, when if it is raised to an even number, your sign will change to the positive, and if it is an odd power of index, then it will remain as negative 1. So hence you can write the last term in this form. For when you have a negative number, okay, negative number in place of b. Okay, so this is how you can get this. So now let's just take an example. Okay, so suppose you have 3x minus y raised to, say, 5. Okay, so this then becomes your n is 5. So you have 5 C0. Now you have 3x raised to 5. Okay, now you keep the plus sign, then you write 5C1, 3x raised to 4 minus y raised to 1. Then you have 5C2, then you have 3x raised to 3, and this will be minus y squared. Then the next one will be 5C3. Okay, and you will have 3x squared minus y cubed plus 5C4, 3x multiplied by minus y raised to 4. And the last one will be 5C5. You will have only minus y over here, minus y raised to 5. Okay, so when this becomes your 1, so now you will have 51 into, so this is 729x raised to 5. Okay, then plus, now your 5C1, if you remember, 5C1 can be written as 5 factorial upon 1 factorial, 4 factorial. 4 factorial can get cancelled with 4 factorial on top, and this is 5. So you have 5 into, over here you have 3 raised to 4. So 3 raised to 4 becomes your 81. Okay. And over here you have the minus sign. Okay. So you will see. Okay. So there is a minus y raised to 1. So this will be minus y. So the sign changes over here. Then you can write 5 into 81 into x raised to 4 y. Okay, over here now you have minus y raised to 2. So this will become positive. So the sign remains the same over here. And this you will get as your 5C2 will be 5 into, say, you have 2 factorial and 3 factorial, 5, 4 into 3. factorial, this gets cancelled, 2, this will be 10. Okay, so then you have 10. Now you have 3 cubed. Okay, so that is your multiplied by 27x cubed, x cubed y. Okay, because positive over here. Now the next one is minus y cubed. Okay, so you will have a negative sign remaining over here. So this sign will change. So this will become minus. Then you have 5c3. Okay, so 5c3 will be similar to your 5c2. Okay, so this again becomes 10. 10. Now you have 3x squared. Okay, so 3x squared will become your 9x squared y. Okay, because y cubed. Okay, sorry, over here forgot in the power of y. Okay, so this will be y squared and this is y cubed. Then the next one you say minus y is raised to 4. So again, because your r over here or your power is even number, your negative sign changes to positive. So this sign remains the same. So you have plus 5c4 is again similar to what we had got for 5c1. So that would be 5 into 3x. Now y raised to 4. Okay. And the last one, you will have 5c5 is 1 and minus y raised to 5. Okay. So as you can see that the last term is, the minus y is raised to an odd number. So you will have a negative sign. So this sign will change. So this will be minus y raised to 5. Okay, so let's just write the final expansion. Minus 5405 x raised to 4y plus 270 x cubed y squared. Then minus, this is multiplied actually, so this is 90 x squared y cubed. Then you have 15 x y raised to 4 and minus y 5. Okay, so you can see that if your b is a negative number, the sign will depend on the the power of the b. Okay, when we are the index of the b when we are doing the expansion. Now the next case. Okay, so case 2. Okay, so the case 2 is when you take a is equals to 1 and b is equals to x. Okay, so we will put a plus 1 plus x in place of a plus b. So you have 1 plus x raised to n. Okay, and then you can expand this in the form of now 1, wherever we have 1 raised to any index, we'll not write it. So it's 1. And over here x is raised to 0. So you will have nc0. Okay, then you will have nc1. Then you will have 1 raised to n minus 1. So that will remain as 1 any which way. So you will have x raised to 1 over here. Okay. Then you have nc2. So 1 raised to n minus 2. So anyway, it will remain 1. And you will get x raised to 2. Okay. Then you have nc3. Next one will be x cubed plus, and then you will have nc n x raised to n. Okay, so this is what we get if we for a case where we have 1 plus x raised to n. Now consider a value for x if x is equals to 1. Okay, if x is equals to 1, what we will get with 1 plus x, then if you substitute for f x is equals to 1. So this will remain the same. Then you will have nc1, okay, and then you have nc2 plus nc3 plus all the way up to ncn. Okay, so suppose we take n. Okay, so 1 plus x raised to say 4. Okay, and x is equals to 1. Okay, so since x is equals to 1, now we will write this entire, coefficient, this expanded form, keeping x as equals to 1 and expanding it up to the fourth, for power of 4. So you will have 4c0 plus now you have 4 nc1. So this is 4c1 plus 4c2 plus 4c3 plus 4c4. Okay. So this will be 1 plus this will be 4. Then this will be 6. This will be 4 again. And this will be 1. So what you get is 5, 5, okay, 10, 10 plus 6, 16. Now, we got 1 plus x is equals to 4. We, actually just substituted for x is equals to 1. But if you write it in the form as, 1 plus 1 raised to 4, so that is 2 raised to 4, that again is 16 itself. Okay. So this is whenever if you are getting that 1 plus x is given to you, okay, and you are given with any suppose your x becomes 1, okay, then what you actually need is 2 raised to n. Okay, and if your x becomes 2, then you will, whatever answer you get, okay, will become kind of 3 raised to n. Okay, so anytime, that's why when we try to solve for say 98 raised to anything n, so we always try to get it in the form of 2n. Okay, so then it becomes easier because we getting any power of 100 and any power of 2 becomes easier for us. Okay, so this is where the relation actually comes. Now the last case is when a is equals to 1 and b is equals to minus x. Okay, so similarly, when you have a plus b, the whole power raised to n, so you can write this as 1 plus minus x raised to n. So what now we will get is n c0, okay, and you don't write, let's not write about the 1 part, okay, because it will be 1 raised to anything will be 1. So then you have plus nc1, you will have minus x, okay, raised to 1. Then you have plus nc2, you will have minus x raised to 2. Then nc3 will have minus x raised to 3 plus all the way up to ncn minus x raised to n. Okay, so this then again will come in the same form as we had seen, when we were doing x plus, where your a is x and your b is minus y. Okay, so now this will remain as nc0. Now the negative sign comes out, so we have 1x, and then minus x squared is x, so you have plus nc2x squared. Now minus x raised to 3 is minus x itself. Okay, so you have minus and nc3 x cube. Then all the way, the last one will be minus 1 raised to n, ncn x raised to n. Okay, so again, the sign will depend on what your n is. So suppose now if we take, x is equals to 0. So just substitute x in this expanded, form. You first one will be nc0. Okay, then you will have this will become 0. Okay, so you will have nc0 minus the entire thing actually ends up being 0. Okay, this will be 0, then this will be 0, then this will also be 0. Okay, all the way up to your this itself. Again, this will become 0. Okay, sorry, this is for x is equals to 1. I'm so sorry. I'll redo it. I got confused over here. So anyway, even if your x is equal to 0, it becomes 1 raised to n, and you can see that if your x is equal to 0, only this term will remain NC0, which is equals to 1. So anyway, 1 raised to anything would be n. But we want to see what will happen if x is equals to 1. So now you have 1 plus minus 1 raised to n. Okay, so you substitute your minus 1 everywhere. So you have NC0 minus NC1. Okay, minus 1, if you get, then you will have this C2 minus 1 raised to 2 plus all the way up to minus 1 raised to n, NCn minus 1 raised to n. Okay, so this is what we get, and similarly, what you are left with is NC0 plus your, this is minus NC1, okay, and then this will be plus NC2, then the next one will be NC3 plus all the way up to, okay, so this is again, this will keep the same because we don't know what your n is, whether you'll have a negative sign or what. Okay, so this will be minus 1n, so this will be, yeah, Cn, Cn. Okay, now suppose we take n is equals to say 5. Okay, so n is equals to 5. What will we get then? So this is 5C0 minus 5C1 plus 5C2 minus 5C3 plus 5C4, and you will have, since your n is 5, it's going to be an odd number, so you will be getting a negative sign, okay, because negative 1 raised to any odd number would be negative itself, so negative NCm. Okay, oh sorry, this will be 5C5. So then this is your 1, okay, 5C1 will become minus 5 over here. Then 5C2 we have seen before that it will be, it is plus 10. This will be 5C3 and 5C2 have the same value, so this will be 10. 5C4 and 5C1 have the same value, so this would be 5. And this will be your minus 1. So this becomes 0. Okay, because if you have 1 plus minus 5, okay, so this in turn actually becomes 0 raised to n. So anything like 0 raised to anything would remain 0. So you can see that the final answer would be 0 no matter what your n is. Okay, so these are all the different concepts and kind of the basic rules that we need to follow, we need to know when we want to solve sums with respect to binomial theorem, binomial expansion. Okay, so now we will go with multiple examples and see what different kind of concepts are actually being used while we want to solve binomial expansion related sums. So, just excuse me. Okay, so suppose we are asked to evaluate x plus 2 by x raised to 4, the whole raised to 4. Okay, so the solution with the binomial theorem of binomial expansion, what we have is you will start with NC0. So n is 4, so 4C0 and a raised to n. So a is x and raised to 4, so x raised to 4. Then the next one is 4C1 x n minus 1, so 4 minus 1, 3 and we will have b raised to 1, so that is 2 by x. Then the next one, you have 4c2 x squared 4 by x squared. Okay, because 2 by x, b whole squared will get 4 on x squared. Next one is 4c3 8 x cubed. Okay, because your r over here is cubed, and then you have plus 4c4 16 by x raised to 4. Okay, now you get all the coefficients. C0 is 1, so x raised to 4. 4c1 is actually going to be 4 multiplied by your x, and x 1x from the numerator gets cancelled, so you have x squared into 2. Then you have 4c2, so that is 6. So multiplied by over your x squared, and x squared gets cancelled, so 6 into 4. Then you will have plus 4c3. 4c3 is similar to your value of 4c1. So this is again 4 into 8 by x cube. Okay, and the last one would be 16 by x raised to 4. So you have x raised to 4 plus 8x squared plus 24 plus 8 into 4, 32 by x cube. And then you have plus 16 by x raised to 4. Okay, so this is what we get for this expression evaluation. Then suppose now you are given evaluate x squared minus 3 by x by 5. Okay, so for this case, we will have 5c0 x squared raised to n over here is 5. Okay, then now since we have a negative sign in between, so if you remember the special cases that we just did, whenever you get a negative sign before your b, your alternate terms will have the opposite sign. So if your first term has a positive sign, your next term will have a negative sign. Okay, so now we will have minus 5c1 x squared raised to n minus 1, so that is 4, and you will have b raised to 1. Then the next sign would be a plus, so 5c2 x squared raised to 3, and this will be 3 by x the whole squared. And then you will have again minus 5c3 x squared raised to 2, and you will have 3x upon the whole raised to 3. Then the next one will be, again you will have a positive sign here, 5c4, you have x squared, okay, raised to 1, so x squared alone. Then 3x raised to 4. Okay, and the last term again would be minus over here. So with minus, we get 5c5 3 by x raised to 5. Okay, fine. So now we, get all the coefficient values, and also, get the values for all the b with respect to the power. So this will be x raised to 10 minus 5. This is x squared. So this will be into x raised to 8. Okay, and x, there is one x in the denominator. So this will be 5 into x raised to 7 multiplied by 3. Okay, then you will have plus 5c2 is 10. Okay, so now this would be x raised to 6, and there is x squared below. So x squared will get will get cancelled out from the numerator and the denominator. So what you are left with is x raised to 4. Okay, and then you have 3 squared, so multiplied by 9. Then you will have 5c3. So 5c3 value is equal to your value that you get by 5c2. So this is 10. Okay, and then multiplied by, there is x cubed below in the denominator, and there is x raised to 4 in the numerator. So x cubed will get cancelled. You will remain with x into, now this will be 3 cubed, so that is 27. Then you have 5c4, so that is equal to your value of 5c1. So this is again 5 into, now there is x4 in the denominator, x raised to 4 in the denominator, and x squared in the numerator. So what you get is 3 raised to 4 is 81 by x squared in the denominator. Okay. And then you have the last term, that is 5c5 is 1, and 3 raised to 5 is 7 to 9, and in the denominator you have x raised to 5. Okay, so now you simplify and get this as 15 x raised to 7 plus 90 x raised to 4, and then you will have minus 270x, and then you have plus 81 into 5, 405 by x squared minus 729 by x raised to 5. Okay, so this is your final answer. Now let's do slightly more, a bit complex kind of questions that some of them have already been asked in your previous, entrance exams also. So suppose the question is given as, if the sum of coefficients of all even powers of x in the product 1 plus x squared plus x raised to 2n, and we have 1 minus x plus x squared minus x cubed plus maybe up to x raised to 2n is 61. What is value of n? Okay, suppose this is what we are asked. Now, if you actually, kind of multiply your the product over here, okay. So the product of 1 plus x squared plus x raised to 2n and multiplied with 1 minus x plus x squared minus x cubed plus all the way up to x raised to 2n can be written as a0 plus a1x. Okay, so like whether you multiply 1 and then 1x, then okay, like that in that form. So the product can be written as a2x squared plus a3x cubed, where your a1, a2, a3 are all kind of coefficients of all the x variables. Okay, and so on. Now, if we put x is equals to 1, okay, in 1 plus uh, in 1 plus x plus x squared plus x raised to n, and 1 minus x plus x squared minus x cubed plus x raised to 2n. Okay. over here if we get, so this actually comes out to be 1 over here, since x is just 1, so you have 1 plus 1 plus 1 plus all the way up to, you will have plus 1. Okay, and this one will be 1 minus 1 plus 1 minus 1 plus 1, or so on till 1. Okay, sorry. So this is what you get. If we put x is equals to minus 1. Minus 1. Okay, and this actually you can write as a0 plus a1 plus a2 plus a3 plus, okay. Over here, how? Because these there will be some terms obviously which would get cancelled. Okay, so you can write it in that form. Now, if you put x is equals to minus 1 in the same thing, okay, in your, say this is your 1, in 1 we get, you will have 1 minus 1 plus 1 minus 1 plus 1 and all the way up to plus 1. And similarly, if you put minus 1 in this, so all your negative signs will actually change into positive. Okay. And all of these actually end up become your positive. So you will have 1 plus 1 plus 1 plus 1 plus the way to plus 1. So this again can be written as, this will become as a minus 1, a1 plus a2 minus a3 plus. Okay, so this is what we get over here. So suppose this is your 2 and this is your 3. Adding 2 and 3, we get, okay, so all your this a1, all these odd coefficients actually get cancelled out. So what we are left with is 2 a0 plus a2 plus a4 plus all the way up to a2n. Okay, now what we see is that the number of coefficients actually, okay, we have 2n, it actually becomes the sum of coefficients is actually 2n plus 1. Okay, and we are given that 2n plus 1. Okay, this can be written as 2 into 2n plus 1. Okay, so similarly 2n plus 1 we are given as 61. So therefore your n is actually is equals to 30. Okay, so this is the answer, the result that we get for the asked question. Let's take another question. Okay, so if alpha and beta are coefficients of x raised to 4 and x squared respectively in the expansion of x plus x squared minus 1 the whole raised to 6 plus x minus x squared minus 1 the whole raised to 6. Okay, then find the value of alpha minus beta. Okay, so this is what we are asked. So we are given, Okay, so the expression that we have got is x plus root of x squared minus 1 the whole raised to 6 plus x minus x squared minus 1 the whole raised to 6. Okay, so let this be your first term and this be your second term. So first we'll expand or expansion of first term. Okay, so that is your x plus, yeah, write it down over here. So that is your x plus x squared minus 1 the whole raised to 6. Okay, so expanding this, what we get is 630 x raised to 6 plus 6c1. Now over here you'll get x raised to 5 and you will write the b part as it is x squared minus 1. Okay, then you will have plus 6c2 x raised to 4. This will be x squared minus 1 the whole squared. Then you will have plus 6c3 x cubed. Then you have x squared minus the whole cube plus 6c4 x squared. This will be x squared minus 1 4. Okay, and then you have plus 6c5 x root of x squared minus 1 the whole raised to 5 plus 6c6. This will be x squared minus 1 raised to 6. Okay, so let this be your first equation or the first statement where it is the expansion of first term. Now we will expand expansion of second term. Okay, so the expansion, the term that we have is x plus, sorry, not plus, this will be minus. So minus x squared minus 1 the whole raised to 6. Okay, so now in place of b, we will put minus x squared minus 1, okay, under root. So then the expansion becomes 6c0 x raised to 6 plus 6c1 x raised to 5 minus x squared minus 1 in brackets and plus 6c2 x raised to 4 minus under root x squared minus 1 squared plus 6c3 x cubed. You have minus x squared minus 1 raised to 3. Okay. Then you will have plus 6c4 x squared minus x squared minus 1 the whole raised to 4 and then plus 6c5 x minus x squared minus 1 5 raised to 5 and the last one will be plus 6c6 minus under root x squared minus 1 raised to 6. Okay, and this will be your second statement. Now what we will do is, as the expression has the addition, okay, the sum of the expanded forms of one, the first term and the second term. Okay, so adding 1 and 2, so these are the expanded forms. We will see, okay, that these negative signs, okay, will actually change your signs of the of the operations between the two terms. So wherever you have odd powers of b, that is under root x square minus 1. Okay, so the signs before that will change. Okay, so for your this will become negative. Okay, then this will become negative, and also this will become negative. Okay, so when they become negative and we are adding, so all the wherever you have odd powers of under root x square minus 1, those terms will get cancelled. So hence what we are left with is, now since we are adding, so we will have 2. Okay, now you will have the first term of both 1 and 2. Then you will have plus 6c2 x raised to 4 under root x squared minus 1 squared. Okay, plus 6c4 x squared x under root x squared minus 1 the whole raised to 4, and the last term 6c6 under root x squared minus 1 the whole raised to 6. Okay, so now if you get all the values of coefficient and also take out the powers, you get this as 6c0, that is 1, so you have x raised to 6. 6c2 is going to be 6 into 5 into 4 factorial, 4 factorial, so this is 3 into 5, so this is 15. Okay, so you have 15 x raised to 4. Now this is squared, so let's write this as x squared minus 1. Then you will have plus 6c4. Okay, so 6c4 is similar to the value of 6c2, so this will be 15. Okay, now this is x squared, and under root x squared minus 1 the whole raised to 4 will actually turn out to be x squared minus 1 the whole square. And the last one is your 66 is 1, so this will be, and under root x squared minus 1 the whole raised to 6 will actually turn out to be x squared minus 1 the whole cube. Okay, so for easier simplification, what we can do is we'll first find the values of these of the parts of the terms where x is involved. So first we will take and find x4 multiplied by x squared minus 1. So this is actually going to be x raised to 6 minus x raised to 4. Then the next one is x squared minus 1 the whole square. So that will be x squared into, you have x raised to 4. So then you will have minus 2ab. So 2 into x squared. And then you have plus 1. Okay. Then the last one is x squared minus 1 the whole raised to 3. Okay. So this will be x raised to 6. Then you have 3a squared b. So 3 into x raised to the square of x squared. So you will have minus 3x raised to 4. Okay. Then you will have plus 3x squared. Then you have minus 1. Okay. So this is what we get. Now your this part then becomes taking 2 inside. So 2x raised to 6. So 2 into 15 is 30. So this entire thing multiplied by 30. So you have 30x raised to 6 minus 30x raised to 4. Okay. Then you will have this. Okay. So this you can write x raised to 6 minus 2x raised to 4 plus x squared. Okay. So substitute this for this. So, and there will be 30 over here. Okay. So you have, oh sorry, this was the previous one. So the minus sign remains over here. Okay, so the minus sign will remain over here. Now over here you will have plus. Now 30 into 30x raised to 6 minus 30 into 2 will be 60x raised to 4, and 30 plus 30 into x squared. Okay, so plus 30x squared. And the last one will be 2 will be multiplied with the entire, the entirety of this term. So you will have plus 2x raised to 6 minus 2 into 3 is 6x raised to 4 plus 2 into 3 6x squared minus 2. Okay, so this is what we get. Now get all the x variables and whatever power they have, all the common terms together. So you have 2 x raised to 6, so this is 32. 32 plus 30 is 62. 62 plus 2, this will be 64 x raised to 6. And then you have x raised to 4 will be the next term. So you have minus 30, minus 60, so minus 90, minus 90 plus minus 6. So this is minus 96. X raised to 4. And the next one we'll have is x squared. Okay, so all the values of x squared. So you have 30x squared and 6. So plus 36x squared, and the last one we have is minus 2. Okay, now in the question we had asked that alpha is the coefficient of x raised to 4 and beta is the coefficient of x squared. So therefore your alpha is equals to, this is not to take power. Okay, so yeah, so alpha is equals to minus 96 and beta is for x squared, okay, coefficient of x squared, so that is 36. So therefore now we were asked what is alpha minus beta. So alpha minus beta then becomes minus 96, and you have minus 36, and this is your minus 132. Okay, so this is your final answer about what is being asked. Okay, so most of the sums, as you can see, that we have done, so we were all kind of dealing with the of the type of x minus y raised to n. Okay, so where this actually turns out to be x plus minus y. Okay, and depending on your n, your sign, okay, the sign between the different terms will be changing, okay, with respect to your n, and also with respect to the r, as like the index of b for the different terms. So this is what we see. So we will stop here today, and in the next class we'll solve a few more examples. A few of them would be much more complicated, where you might have to use other kind of other concepts also. So thank you for attending. We'll see you in the next class. So